Gemini AI has just taken a step that could change robotics forever. Google's Gemini 1.5 models are no longer just powering chatbots, search assistants, or productivity apps. They're now driving actual robots, and not in the limited, pre-programmed sense we've seen before. These robots can reason step by step, plan ahead, use digital tools like search, and even transfer what they learn from one kind of robot to another. That last part is huge, because it means we're closer than ever to general-purpose robots. Machines that can work in real-world settings the way humans do, not just in carefully staged demos. Welcome back, guys. Alfie here with another groundbreaking update. Gemini AI just crossed a line. Robots now plan, reason, and use tools like humans. So, as always, we're here to keep you at the forefront of the future. Let's get into it. The first big breakthrough here is reasoning. In the past, robots, even the advanced humanoids we've seen from Tesla, Figure, or Boston Dynamics, relied on separate control systems that translated commands into physical motions. They could walk, pick things up, or follow specific instructions, but they didn't actually think through the problem like a human would. With Gemini 1.5, that's different. The robot doesn't just hear a command like sort the laundry and blindly start moving. Instead, it pauses to plan. You can literally see its thought process as it breaks the task into steps. Identify the clothing items. Determine which pile they belong in. Move each item accordingly. And only then does it begin acting on those steps. This is the closest we've seen to a robot engaging in actual reasoning, deciding what to do before it starts moving. That distinction matters. It's the difference between a robot that's basically a programmable arm and a robot that can operate in unpredictable environments. A washing machine can wash clothes, but it can't figure out what belongs in the wash in the first place. A Gemini-powered robot can. Another stunning piece of this breakthrough is that all the robots are using the same underlying Gemini models. Whether it's Apollo, Google DeepMind's humanoid research platform, or smaller platforms like Aloha and the Biarm Franca, they're all plugged into the same brain. Normally, robotics is siloed. One robot might be great at manipulation tasks, another at walking, another at navigation. Training each one takes time, money, and huge amounts of data. But Gemini 1.5 is showing something new, a kind of transferable intelligence. What the robot learns in one setting can be applied in another. If Apollo learns how to fold a towel, Aloha doesn't need to start from scratch. It can inherit that knowledge through the shared Gemini backbone. This is exactly how humans operate. Once you learn how to solve a puzzle, you can apply that logic to different but similar puzzles. This makes robotics far more scalable. Instead of building narrow, task-specific bots, companies can finally move toward general-purpose helpers that adapt to multiple environments without retraining every time. Now here's where things get really wild. Gemini-powered robots aren't just limited to their onboard sensors and preloaded instructions. They're gaining agentic power. That means they can use digital tools, like search, to solve problems in real time. Imagine asking a robot to cook you a meal it's never made before. A traditional robot would fail because it only knows what it's been trained on. A Gemini robot could search for the recipe online, read through it, break it down into step-by-step instructions, and then execute those instructions in your kitchen. This isn't science fiction. Google is already demonstrating that these robots can query the internet to fill in their gaps. If they don't know how to do something, they can look it up. That's the same skill that makes humans so adaptable. We don't memorize everything. We rely on external tools, whether that's Google, YouTube, or a good old-fashioned cookbook. For robots, that's a line we've never seen crossed before. They're no longer just pre-trained machines. They're becoming active problem solvers. When Sundar Pichai took to X to share the video of Gemini Robotics, it wasn't just a casual update, it was a statement about the direction Google sees the future heading. Pichai highlighted that these new models are capable of reasoning step by step before acting. That small phrase, step by step, might sound ordinary, but in robotics, it's groundbreaking. Because step-by-step thinking is what separates mindless execution from true intelligence. Think about it. Humans don't just react. We pause, plan, and then act. That's what makes us effective at handling messy, unpredictable environments. For decades, robotics has struggled with this. A robot might be great in a controlled demo, but useless in the real world because it can't improvise. Gemini's step-by-step reasoning is the missing ingredient that could change all that. Let's talk about that demo video. On the surface, it shows a Gemini-powered robot sorting laundry. Cute, right? Not exactly groundbreaking. We've seen robots fold shirts before, but the point wasn't the laundry. The point was how the robot approached the problem. Instead of following a hard-coded routine, it actually thought through the task. It considered each item, reasoned about what to do with it, and executed based on its own plan. That's fundamentally different from a pre-programmed demonstration. Laundry was just the test case. The real message was, if robots can reason their way through sorting laundry, they can reason their way through 1,000 other unpredictable household or workplace tasks. And that's the holy grail of robotics. Robots that can adapt, not just repeat. This breakthrough pushes robotics toward the vision everyone's been chasing: general-purpose robots. Right now, most robots are specialized. A warehouse robot moves boxes, a delivery bot carries packages, a hospital robot delivers medications. Each is locked into a narrow role. But if Gemini 1.5 can truly reason, plan, and transfer knowledge across platforms, the future changes. Suddenly, you don't need 10 different robots for 10 different tasks. You need one adaptable robot that can learn, search, and figure things out as it goes. That's why this is being called a line-crossing moment. We've officially stepped out of the era of dumb, specialized machines and into the dawn of adaptable, intelligent agents. Let's drill down on transfer learning for a second, because this is one of the most powerful parts of the Gemini Robotics project. Traditionally, teaching a robot to do something new is expensive. You need hours of training, data collection, and fine-tuning. And once you're done, that knowledge stays stuck in that one robot. With Gemini, that wall comes down. When one robot learns a skill, others can inherit it through the shared model. This is exactly how humans scale knowledge. One person figures out how to invent fire, and suddenly the entire community benefits. One person writes a manual, and millions can learn from it. That's the level of scalability Google is hinting at here. It means progress in robotics will no longer be siloed experiments. It'll be a collective climb toward general-purpose intelligence. Another reason this breakthrough matters is that Gemini robots aren't just reasoning, they're using tools. And tool use is one of the hallmarks of human intelligence. Anthropologists often point to tool-making as the defining leap that separated humans from other primates. Now we're watching robots cross that same threshold. They're not just moving their own arms. They're reaching into the digital world to pull in extra resources. A robot that can Google instructions, or tap into a calculator, or analyze a map online is exponentially more powerful than one that can't. This agentic ability is how we move from robots that just do to robots that actually solve. Make no mistake, this isn't just a nice academic demo. This move shakes up the entire robotics industry. Companies like Tesla, Figure AI, and 1X are all racing toward a GI-powered humanoids. Their demos have been impressive, walking, grasping, manipulating, but until now, none of them have shown robots with true agentic reasoning tied to internet tools. Google just showed it, and that gives them a massive advantage. Think about it. Tesla Optimus may have cutting-edge hardware, but if Gemini robots can think, plan, and search in real time, Google just leapfrogged the competition in intelligence. And in robotics, intelligence is what will ultimately decide who wins. Hardware can be copied. Reasoning ability is harder. All of this leads to one huge question. Are we ready for robots that can plan, reason, and use tools like humans? Because this isn't just a technical leap, it's a societal one. Robots that can independently query the internet and reason through problems are much closer to autonomous agents than to simple machines. That raises questions about safety, alignment, and control. If a robot can search the web and take action, how do we ensure it only uses safe sources? If it can transfer skills across platforms, how do we prevent dangerous knowledge from spreading? And if it can plan step by step, how do we make sure those steps always align with human goals? These are the debates we're going to see more of in the coming months. Because the technology is already here. The question is how we choose to use it. But that kind of intelligence also raises another big question. What do these robots actually cost? Because when you start climbing the price ladder, the numbers get absolutely insane. On one end, you can grab a robot for just $10. But on the other end, there are humanoid machines and specialized systems worth over $1 million. That's not a typo, $1 million for a single robot. At the $10 mark, we're not getting anything close to a robot that can think or interact. What you're holding is usually a toy robot, something you'd find on a discount shelf or in a kid's party bag. Think tiny plastic bots that shuffle around when you wind them up, or battery-powered little guys that walk awkwardly across the table. They don't have sensors, they don't have intelligence, they're essentially novelty machines. But here's the fun part. For many kids, this is their first introduction to robotics. A $10 robot shows the very basics, movement, gears, maybe even flashing lights, and that tiny spark can actually inspire curiosity. A lot of engineers today will tell you they got into robotics because of a cheap toy robot they played with as a child. So while it's not useful in a practical sense, the $10 robot is important because it plants the seed. Now, when you bump the budget to $100, things start to get interesting. This is where you'll find educational robot kits like Lego Mindstorms, Arduino-based bots, or smaller programmable cars. Here, you're not just watching a toy move around. You're actually building and coding the robot yourself. Many of these kits come with line-following sensors, obstacle detection, and Bluetooth controls so you can drive them with your phone. For kids, this is where they start learning actual robotics principles: sensors, motors, loops, and commands. For adults, it's an entry point into DIY robotics without breaking the bank. Another example around this price is robots like the Sphero Bolt, a programmable rolling robot ball that teaches coding while being super fun to play with. At $100, robots start bridging the gap between toys and learning tools. They're not just fun anymore, they're educational and hands-on. At $250, robots start to feel alive. This is the range where we find consumer AI robots like Anki Vector or its predecessor, Cosmo. These aren't industrial machines, but they're packed with personality. They can recognize your face, respond to your voice, and even show emotions with little animations. Vector, for example, could roam around, react when you touched it, and even respond to questions with built-in Alexa integration. This is a big leap because at this stage, robots go from being programmable toys to companions. They feel like they have personalities, and kids and even adults get attached to them. At $250, you're buying a robot that blends entertainment, AI, and interaction in a way that feels futuristic, even if it's limited compared to the big players. Crossing the $1,000 mark takes us into the territory of serious consumer robotics. Here, you'll find small humanoid robots like the Robotas Mini or the more advanced DIY humanoid kits. These robots can actually walk, wave, and perform gestures that mimic human movement. They're often used in schools, labs, and hobbyist projects. Another big category at this level is robotic vacuums and mops. While cheaper ones exist, the top-tier models like the Roomba J7 Plus or Roborock S8 Pro Ultra cost around this much and are fully autonomous. They map your home, avoid obstacles like socks and pet messes, and even empty themselves into docking stations. This is the first tier where robots become genuinely useful in everyday life. They're not just fun or educational, they're doing real work that saves you time. Now we're talking serious robotics. At around $5,000, you start to see robots used in education, research, and small businesses. For example, the Nio humanoid robot by SoftBank often falls in this range. Nio can dance, recognize speech, detect faces, and hold conversations. It's used in classrooms around the world to teach coding, robotics, and even to help kids with autism practice social skills. On the other hand, this is also where you'll find robotic arms like the U-Arm Swift Pro or entry-level industrial manipulators. These can be programmed for precise tasks like sorting, 3D printing, or even delicate assembly. At $5,000, robots become multi-purpose: education, light manufacturing, and even therapy. This price point is a gateway into professional robotics. Doubling the budget again takes us into even more advanced territory. At $10,000, you'll find robots like the Unitree Go 1 Pro robot dog. This quadruped robot can follow you, carry a payload, and navigate outdoor environments. It's not just a toy, it's a serious research platform used by developers worldwide. You'll also find medical exoskeletons in this price range, robotic suits that help people with mobility issues stand, walk, and regain independence. Imagine the life-changing impact of a robot that allows someone paralyzed from the waist down to take steps again. At $10,000, robots start showing life-changing utility. They're no longer just about convenience. They're about human impact. At 20 grand, the robots get rugged and professional. This is where you'd find early versions of Boston Dynamics Spot or advanced quadrupeds capable of 3D mapping and autonomous navigation. These machines are used by firefighters, police forces, and inspection teams to go places humans can't. For example, Spot has been deployed in disaster zones, chemical plants, and underground mines to inspect dangerous areas while keeping people safe. This price point represents the shift from labs to the field. Robots are no longer experiments, they're actively working alongside humans. At $50,000, you can buy the full commercial version of Boston Dynamics Spot. This is one of the most iconic robots in the world, and it's actually available for businesses to purchase. Spot can climb stairs, open doors with attachments, carry sensors, and patrol construction sites autonomously. It's essentially a robot worker for inspection and surveillance. This is also the range where some small startups sell custom humanoid research robots, machines designed for universities and labs to experiment with human-like movement. At $50,000, robots are practical investments for businesses, not just tech demos. At 6 figures, robots become the backbone of entire industries. We're talking KUKA, ABB, and FANUC industrial robotic arms, the massive orange machines you see in automotive plants. These robots can weld car frames, move giant metal panels, and assemble components with unmatched precision. They're not glamorous or cute like humanoids, but they're the reason factories can produce millions of cars, electronics, and consumer goods every year. At this price, robots are infrastructure, invisible to most of us, but essential to modern life. At $250,000, we're stepping into humanoid territory. Robots like a mecha by Engineered Arts cost around this much. A mecha is the world's most realistic humanoid, capable of facial expressions that are almost indistinguishable from humans. It can frown, smile, raise eyebrows, and engage in conversation with natural gestures. A mecha isn't designed to wash dishes or work in factories. Instead, it's built as a platform for AI research and demonstrations. Companies use robots like this to test conversational AI, experiment with human-robot interaction, and showcase what the future of robotics might look like. At $250,000, robots are more about exploring humanity's future than solving practical problems today. And finally, the top of the ladder, the million-dollar robots. This is where you'll find Boston Dynamics' Atlas Humanoid, Tesla's prototype Optimus Humanoid, and surgical robots like the Da Vinci Xi system. Atlas can run, jump, backflip, and manipulate objects with incredible dexterity. It's a research prototype, not for sale, but the development cost per unit easily hits 7 figures. The Da Vinci Xi, on the other hand, is used in hospitals for robotic-assisted surgeries. It allows surgeons to perform incredibly precise operations with less risk and faster recovery for patients. $1 million sounds expensive, but when you realize this machine saves lives and is used daily in operating rooms, it makes sense. At this tier, robots are no longer about gadgets, education, or even jobs. They're about reshaping humanity itself, how we heal, how we build, and how we define the line between human and machine. So, what did our ladder teach us? At $10, robots are toys. At $100, they're educational. At $1,000, they start being useful. By $50,000, they're working professionals. And at $1 million, they're reshaping industries, medicine, and even what it means to be human. The wild part is, this ladder is shrinking fast. The million-dollar capabilities of today will likely cost $100,000 or less within the next decade. Robots are getting cheaper, smarter, and more accessible every single year. And while we've just seen how robots evolve as the price tag climbs, the real story isn't just about cost, it's about intelligence. Because right now, companies aren't competing over toy bots or industrial arms. They're racing to build the first true AGI-powered humanoid.